Hello everyone and welcome back to our channel. Today we will analyze the progress that the James Webb Space Telescope has made so far in preparation for deep space exploration. But before we begin, take a moment to show us your support by liking this video and subscribing to our channel. And with that, let's take a look at the James Webb Space Telescope. Ever since the James Webb Space Telescope was launched on December 25, 2021, everyone has been eagerly waiting to see what it will discover about our universe. However, the images that it is set to capture will be unlike any other. Scientists are prepared to learn more about our universe and beyond through these images. Over the past few months since its launch, this next-generation telescope has been quite busy with deployments, alignments, and cooling down, among so much more. The Webb team and NASA are working to remove any minor residual positioning errors in the primary mirror segments. In addition, this incredible instrument has already cooled down to its operating temperature. This even brings it closer and closer to being completed. According to NASA, the James Webb Telescope is currently on Step 7, Stage 3 of the iterative alignment for the final correction process. This is the final step of mirror alignment. Since Webb mainly works with infrared, it is required to be extremely cold. This means the entire instrument, including the various crucial instruments, and thanks to the sun shield and other components, the James Webb Telescope is even closer to being ready for deep space exploration. But what progress has the James Webb Telescope made so far? And better yet, what's next for the telescope? Since the telescope was launched last year, NASA has been suggesting that it will be completed by summer. They specifically say that we will have received the very first clear images by June. And by the looks of the progress that the telescope has made so far, we can say that they are right on schedule. A few days ago, on April 21st, NASA posted on Twitter saying, "Is Webb at its final temperature?" Almost. All of the Webb's instruments have reached their super cold operating temperatures, but the mirrors still have a bit of ways to go. Remember, the colder the mirrors, the better we can unfold the universe. Not so long ago, we saw the mid-infrared instrument, MIRI, reach a very cold operational temperature. About a week ago, NASA continued with the task of commissioning the Webb telescope. Having achieved the successful cooling of MIRI through to the critical pinch point, they managed to cool it all the way to its final operating temperature of a little less than 7 kelvins, which is about minus 447 degrees Fahrenheit. This was one of the things that had to happen before the 7th and last stage of mirror alignment could be done. Next, the team has to carry out the initial checkouts of MIRI as they proceed to the final stages of multi-instrument, multi-field alignment, which includes all 4 science instruments. Not so long ago, NASA announced that the mid-infrared instrument on the James Webb Telescope had attained a temperature just below 7 kelvins, thanks to the gaseous helium cryocooler, which was in its final stage. The Webb team is now operating this incredible telescope as part of the 7th and final stage of aligning the telescope. This is just after they applied the field of view correction during the 6th step. Now the major thing that is left to do is address the removal of any small residual positioning errors in the primary mirror segments. NASA will measure and make any major corrections using the fine phasing process. Then they will perform a final check of the image quality across each of the science instruments. Once they verify this, they will have completed the wavefront sensing and control process. As the team performs each of the 7 steps of mirror alignment, they may discover that they need to iterate earlier steps as well. This process is flexible and modular, allowing for the duration. After about 3 months of aligning the telescope, the team will now be ready to proceed with commissioning the instruments. Once the instruments become operational, the detectors and electronics produce heat. The cryocooler balances this heat to make the myriad as stable as possible and very cold. The near-infrared instruments also warm up during operations, and they have to dissipate heat. For these instruments, this is achieved with passive cooling. This heat, which emerges from the detectors and electronics, is radiated into deep deep space. However, since the instruments are at their operating temperatures, the telescope mirrors still have to cool down to their final temperatures, though they still have a long way to go. Both the primary and secondary mirrors are made of beryllium and coated with gold. Beryllium has a longer thermal time constant at cryogenic temperatures. This means that it would take a long time to cool or even heat up. So far, the primary mirror segments are still cooling down very slowly. The secondary mirror is hanging out of its support structure, and it is a long way from any heat sources. It is currently the coldest mirror, with a temperature of 29.4 kelvins. As for the 18 mirror segments, their temperatures range from 34.4 kelvins to 54.5 kelvins. One of the most significant advantages of beryllium mirrors is that they don't change their shape with temperature, like glass mirrors would at these temperatures. This means that the temperature range does not affect the telescope alignment process in any way. Right now, 4 out of the 18 mirrors are above 50 kelvins. These 4 mirror segments are already emitting some infrared light, which reaches the mirror detectors. Since all the mirror segments are now below 55 kelvins, scientists expect MIRI to start its expedition soon since it will be sensitive enough. However, any additional cooling to these mirrors would enhance their performance. The team behind Webb hopes that the mirrors will cool by an extra 0.5 to 2 kelvins. So, with where the Webb telescope is so far, what are the steps in the final steps? When can we expect to see the telescope fully functional? As mentioned before, Webb is in its final stages. The team is performing some final corrections, which are crucial to the telescope's temperature and its components. It is very important to point out that the angle between the sun shield's presence and the sun is known as a pointing altitude. The amount of residual heat that makes its way through the 5-layer sun shield to the primary mirror depends on this altitude. Because the temperature of the mirror segments doesn't change very quickly, the temperature only changes because of the altitude that is averaged over a number of days during the commissioning process. The James Webb Telescope is currently spending more of its time pointed at the ecliptic poles, which is a comparatively hot attitude. When the scientific operations begin, the James Webb Telescope will have a much more even distribution of pointing over the sky. The average thermal input to the warmest smearing segments is expected to be reduced by a small margin, while the mirrors cool down a little bit more. Later on, as NASA is commissioning the telescope, NASA is planning to test the thermal dependence of the mirrors on the altitude. The agency will first point the telescope at a hot altitude for a couple of days, then later point it at a cold altitude for several days. This is a process that they call thermal slew. This whole process is set to be carried out soon for the team to assess the observatory's optical performance at different thermal conditions, which will be caused by a slew of about 45 degrees in pitch. For at least 4 days, the observatory will be thermally stabilized at a hot attitude before it is slewed to a cold attitude for another 14 days, and finally reoriented back to its hot attitude. This way, it will have completed the test. At each attitude, the observatory will be pointing at wavefront stability, which is measured as a change in the wavefront error, WFE, given the initial hot to cold slew and the final call to hot slew. The WFE and pointing are expected to drift as the thermal condition of the observatory changes. This test will help verify the integrated modeling predictions of stability that will then be used to predict wavefront drift during the normal science observations, as the observatory carries out its observing programs. Once these tests are completed, NASA will be ready to carry out scientific observations. They are very hopeful that they will be done by the summer, and they will have started observing by then. But as of now, NASA still has to make sure that all the instruments are working perfectly. What do you think of the James Webb Telescope's progress so far? Let us know in the comment section below. Thanks for watching, and I'll see you in the next one.